Okay, so now we're going to do question 9. 9.1, the graph of g of x is equals to x cubed plus bx squared plus cx plus d is sketched below. The graph of g intersects at x-axis of -5 and 0 and p. The y-axis is given as 0 and 20. So p and r are the turning points of the graph of g, right? So the information is represented in this graph, as you can see. So we're having the x-intercept here and here. So this one is the x-intercept and the turning point of the graph. And then this point here, it's your y-intercept where x is 0. Then this r is going to be your turning point of your cubic function. So 9.1.1, we are asked to show that b is equals to 1, c is equals to -16, and d is equals to 20. So what we can do here is this. We will write our g of x in terms of x1 minus, we're having our x-intercept to be -5, right? So you can just write -5 here, and then x, let me just rewrite this formula here. So you have g of x being equals to x minus -5, right? And then x minus x1, right, squared. So this portion here is just this -5, and then this portion here it's this p, right? The reason why it's squared, it's because it's an x-intercept and also the turning point of the graph of g of x, right? So hence I did that. Then you're going to have g of x being equals to x plus 5 x minus x1, right, squared. So what you're going to do here, we can substitute this 20 here, so 0 and 20. So where is g of x, we're going to put 20 is equals to, and then where you see x, this x here, you're just going to put 0. 0 plus 5, 0 minus x1 squared. And then it's 20 is equals to 5 multiplied by x squared 1, right? Divide by 5 both sides, and you should get x1 squared being equals to 4. And then you put the square roots both sides. So x1 is equals to plus or minus 2. So it's definitely not going to be -2 because the turning point is here, and the x values are positive on this side. So therefore, we will take x1 to be equals to 2. So we now have our x1, so we can simply write our function. G of x is equals to x plus 5 and x minus our x1 is positive 2. So we just write positive 2, and then we close the bracket to put square there. So g of x is equals to x plus 5 and x minus 2 squared, right? And then we're going to find the product because we want to find the standard form of this function here. So it's going to be x plus 5, x minus 2, x minus 2, and then g of x is equals to x plus 5. Then you find the product of this one here, and we'll get x squared minus 4x plus 4, right? So g of x is equals to, so we're just going to find the product of this and this, which should give us x cubed and x multiplied by -4. So it's minus 4x squared, and then x multiplied by 4, so it's going to be plus 4x, and then plus 5x squared, which is this 5 here multiplied by this x squared, and then minus 20x, which is the same 5 multiplied by minus 4x, and then plus 20, which is the 5 multiplied by the 4. So let's collect the like terms of this function here, and we're going to say this x cubed and then minus 4x squared plus 5x squared is just going to be positive x squared, and then plus 4 minus 20 is going to be minus 16x plus 20. So this is your g of x, where you have your value of a being equals to 1, your value of b being equals to 1, your value of d being equals to minus 16, your value of c, being equals to minus 16, your value of d being equals to 20. So we've proven that b1 is equals to, b is equals to 1, right? And we've proven that c is equals to minus 16, and we've proven that d is equals to 20. So we're done with this question here. Let me just erase. There's 9.1.2. Calculate the coordinates of P and R. So you want to identify the turning points of the function, right? And we already know the function is equals to x cubed plus x squared minus 16x plus 20, right? So to find the turning points of this function, we find the first derivative is going to be 3x squared plus 2x minus 16, right? And then f prime of x being equals to 0, so you're going to have 3x squared plus 2x minus 16 equals to 0. And we're just going to factorize this function here, and having 3x and x there, and we have factors of 16, it's 8 and 2, right? And this will take the sign of the middle term, and this would be negative. So it's 3x plus 8 equals to 0, or x minus 2 equals to 0. So we transpose the 8 to the other side and the minus 2 to the other side. We have 3x is equals to 8, or x equals to 2. So we divide by 8 both sides, divide by 3 both sides. So it's going to be divided by 3, so x is equals to 8 over 3. So this would be the answers here. Just to correct, make a correction here. It's actually minus 8, so we divide by 3 both sides, so x equals to minus 8 over 3. So that is the x values of our turning points. Then we want to substitute to our function of f. So f of x being equals to x cubed plus x squared minus 16x plus 20. So we're going to substitute our x of minus 8 over 2 over 3. Why am I substituting this value and not x equals to 2? It's because x equals to 2 is positive, right? And it's telling me that the turning point is for this one, of which I know the y value here is 0, right? So if I were to indicate the turning point for this one, it's simple. I'm just going to write 2 here and 0. So this turning point is finished. It's just substituting this one here, which is equals to minus 8 over 3 cubed plus into 8 minus 8 over 3 squared minus 16 into minus 8 over 3 plus 20. So you punch the entire thing in your calculator. So this is a negative. Let me just put it there. So yeah, you plug in everything inside your calculator, you should get fx of minus 8 over 3 is equals to 1372 over 27, which is basically 50.81, right? This value here is equals to minus 2.67. Cool. So that is our r, our coordinate of r, which is minus 8 over 3 and 1372 over 27. So that is our turning point of r, this one here. So let me erase here. So let me write the coordinates. It's going to be minus 8. Let me write it properly. It's going to be minus 8 over 3 and 1372 over 27. So erase here. So then we go to 9.1.3. Is the graph concave up or concave down at this point here? Show all your calculations. So what you're going to do here is this. We're having our g of x, right? Our g of x is given as x cubed plus x squared minus 16x plus 20. And the first derivative of this function is 3x squared plus 2x minus 16, right? And to find the point of inflation, to find the concavity, you need to find the equation of the point of inflation. So it derived twice, right? And equals to 6x plus 2, right? What we need to note is this. They said we must determine the concavity of this function at this point here of 0 and 20. So you're just going to substitute 0 and 20. Let me just put the brackets properly here. So 0 and 20. So which means the second derivative, you're going to put x being 0. So it's 6 into 0 plus 2. So which means it's 2g of prime of 0. So what I need you to note is this. When the second derivative is greater than 0, it means that your cubic function is concave up, right? It's just saying that it defines the concavity of the function, and it says it's concave up. So when the second derivative is less than 0, it just says that it's concave down, right? So in this case, our second derivative is greater than 0. It's actually equals to 2. So it confirms that the final answer here is going to be this one here, which is concave up. Okay. So now we're going to do this section here. It says that if a cubic function, if g is a cubic function, so I'm just going to explain each and everything that's written here. G of 3 is equals to g of prime of 3 is equals to 0. So let's first explain this first portion here, which says g of 3. So g of 3, it's equals to everything that is here, right? It's equals to, it's also g of 3, it's also equals to 0, right? This 0 here. So what this means is this is the x-intercept when this y is equals to 0, right? Y is equals to 0. So this, let me just indicate here, g of 3 equals to 0. This is the x-intercept when y is equals to 0, fine. So now I've explained the small portion. And then the g prime of 3 is equals to 0. So what this means is the turning point. Remember, when you derive the turning point and you equate to 0, you find the x values of the turning point, of which this x value of the turning point is equals to 3, right? So now we know g prime of 3 equals to 0. It's the x value of the turning point. So the x is equals to 3. Fine. And then let me explain something else here. So now I'm done with this part here. So now I'm gonna explain this one here. So g of 0 is equals to 27. So you see this is just a function of a cubic function when x is equals to 0, your y is 27. So this is your y-intercept. I'm just going to use another color. So g of 0 is equals to 27. So this is your y-intercept when x is equals to 0. Fine. So, and then what else should I explain? I'm going to explain this, which is what I explained just in this previous question that we just did in 9.1. I explained. I said when you have the g prime prime of x greater than 0, when you have the second derivative being greater than 0, where x is less than 3, this tells you the concavity of the function, right? I said this, when it's greater than 0, it's concave up, right? It's concave up, right? And then you have g prime prime of x less than 0, this portion here, where x is greater than 3. So the fact that we have this less than 0, concave down, always know that. Then now it's easy for us to draw the function. I'm just going to draw it here in this small space so that you can see everything that we interpreted. So it's going to look something like this. And then the first thing we're going to do, let's indicate the y-intercept, this one here. Y-intercept is equals to 27, so we have 0 and 27. That's the first point. Let's see the x-intercept, and when y is 0, this one here. So we're done with this one. Now we're here. The x-intercept where y is 0, so x-intercept is equals to 3, so it's here. 3 and 0. So we're done. I'm just going to tick everything that we just finished. So this we're done. And then we are here now. G of prime of 3 is equals to 0. So it means the turning point is equals to, the x value of the turning point is actually equals to 3, right? So which is exactly what we just indicated here. So which means the x-intercept is also the turning point of the function. So we still consider this, so which means we're done with this statement here. And the critical part is this one now. Now that you've indicated your points, this is the critical part, this one here, the concavity. So just before x, when x is less than 3, we're talking about these 3 here. When x is less than 3, right, we're looking at this direction. So when x is less than 3, your g of prime of prime prime x is greater than 0, so which means it's concave up. It is a smiley face. It's this one. It looks like this, but obviously we can't write everything because it's a cubic function. We can simply write one portion, which is this one here on the left hand side. This portion here, we can simply write that. So which means it's concave up, right? Concave up. So let me see which color can I use to draw this. Let me use this one here. So it's concave up, so it's gonna look like this, right? Cool. So it's just gonna continue like this. And then now let's look at this part here. Alright, g of prime prime of x is less than 0 when x is greater than 0. So when x is greater than 0, it's concave down. So now it's set like this. So, but we're just going to consider this portion here. So we're just gonna say it's going down, concave down, right? So that is how our function look. Function of g, we made sure that we indicated all the intercepts and we labeled our x's. So this is y and this is x, right? And yeah, that's how you draw the function. So please don't forget how to interpret the concavity of the function. And yes, hope it was simple enough to do.
Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comments section below. Don't forget to subscribe to the channel for more videos.